Time is not what you think it is. Let me start with something uncomfortable. Right now, you believe there is a single moment called now. You think everyone on earth is sharing it with you. You think the universe has a present moment sweeping forward like a cosmic clock. It doesn't. There is no universal now. And that's not philosophy, that's physics. If you and I are moving differently through space, we literally disagree about what is happening right now, somewhere else in the universe. Not metaphorically, not emotionally, physically. That should disturb you, because it means the present, the thing you think is most real, depends on how you move. Let's take this apart carefully. One simultaneity is not absolute. Let's slow this down, because this is where your intuition quietly collapses. Imagine a very long train moving at a steady speed, not accelerating, just gliding smoothly along the tracks. In the exact middle of that train, there's a passenger sitting calmly with a flashlight and a perfectly synchronized clock. Outside, standing on the platform, there's you. You also have a clock, and let's assume both clocks are perfect. Now suppose two lightning bolts strike the train at the exact same moment, one at the very front, one at the very back. From your position on the platform, you see both flashes at the same time. The light from the front strike and the light from the back strike reach you simultaneously. You measure carefully. You account for the equal distance. You conclude those two events happened at the same time. Simultaneous. Clean. Simple. Obvious. Now shift perspectives. The passenger inside the train is sitting exactly halfway between the front and the back, at least from their point of view. But here's the catch. The train is moving forward. When the lightning strikes, the light from both ends starts traveling toward the middle passenger. But while the light is traveling, the train and the passenger are moving forward. So what happens? The passenger is moving toward the light coming from the front strike and away from the light coming from the back strike. Which flash reaches the passenger first? The one from the front. Not because the front lightning happened earlier. Not because the back lightning was weaker. But because the passenger moved toward one beam of light and away from the other. So from inside the train, the passenger concludes something different. The front lightning strike happened before the back one. Now stop. We have two observers. Both are in constant motion relative to each other. Both are using correct physics. Both are measuring honestly. Both have synchronized clocks in their own frame. And they disagree about whether the two lightning strikes happened at the same time. Who is wrong? Neither. That's the crack in reality. In Newton's universe, this would be impossible. Time was absolute. It flowed the same everywhere. If two events were simultaneous for one observer, they were simultaneous for everyone. Period. But Einstein noticed something subtle and devastating. The speed of light is constant. No matter how fast you move, light moves at the same speed relative to you. That single fact forces everything else to bend, because if light must always move at the same speed, then observers moving differently must disagree about distances and time intervals in order to keep that speed constant. So simultaneity breaks. And this isn't about perception or delay or who saw it first. It's deeper than that. You might try to argue, well, of course the passenger sees one flash first. They're moving. But that misses the point. This is not about when the light arrives. This is about when the events occurred. Each observer, after correcting for the travel time of light and carefully synchronizing clocks in their own frame, still concludes a different order of events. For the person on the platform, the strikes happened at the same time. For the person on the train, the front strike happened first. These aren't opinions. These are calculated conclusions based on the structure of space-time. And here's the part that should unsettle you. If two events are separated in space, meaning they don't occur in the same place, then whether they happen at the same time depends on your motion. Simultaneity is not absolute. It's relative. Now let's stretch this idea beyond trains and lightning. You look up at Mars and ask what's happening right now on Mars. You assume there is a meaningful, universal answer to that question. But according to relativity, there isn't. If you are standing still relative to Earth, your definition of now on Mars slices space-time one way. If you're moving toward Mars in a fast spaceship, Your slice tilts differently, and that tilt changes. Which events on Mars count as now? Two observers moving differently through space will disagree about which distant events are happening at this very moment. Not by milliseconds, potentially by large amounts, depending on speed and distance. There is no single cosmic clock synchronizing Earth and Mars. There is no universal timestamp labeling events across the galaxy. Your now extends outward in a particular geometric direction through space-time, and someone moving differently draws a different line. Imagine space-time as a four-dimensional structure. Your present moment is like a flat slice cutting through it. Change your motion, and that slice rotates slightly. Different slice, different set of events labeled present. The past and future of distant objects shift depending on how you move. That means the idea of a shared global present, one giant synchronized moment across the universe, simply doesn't exist. It feels like it should, but physics says no. Your now is local. It's defined by your motion, your frame of reference, your path through space-time. And that is deeply strange because your brain was built to assume otherwise. You wake up, you check the time, you assume the entire world shares that moment with you. You imagine that somewhere on the other side of the planet, someone else is living the same now. But strictly speaking, even on Earth, observers moving relative to each other, airplanes, satellites, rotating surfaces, already experience tiny disagreements in simultaneity. They're small at everyday speeds, but scale it up, increase the velocity, increase the distance. The disagreement grows. At high enough speeds, events that you consider future can become present for someone else. That's not science fiction. That's geometry. So when you say the universe is happening now, you're making a statement that has no absolute meaning. The universe does not come with a built-in present tense. It contains events. It contains relationships between events. It contains space-time intervals. But it does not contain a universal clock ticking in the background. Simultaneity, the idea that two distant things are happening at the same time, depends on motion. And once you accept that, the comfortable idea of a single flowing present dissolves. Your now is not universal. It's personal. Not psychologically personal. Physically personal. And that realization is the first step toward understanding just how strange time really is. Two time and space are not separate. You were taught that space and time are different things. Space is where things are. Time is when things happen. That sounds reasonable. It feels obvious. You measure space in meters. You measure time in seconds. Different units, different concepts. Case closed. Except it's wrong. Space and time are not separate ingredients of reality. They are fused together into a single structure, space-time. And once you understand that, everything changes. Let's begin with something simple. Imagine you're sitting completely still in a chair. You're not walking, not running, not driving, just sitting there. You might think you're not moving at all, but you are moving through time. Every second you travel 1 second into the future. Now imagine you start walking across the room. You're moving through space. Here's the strange part. The faster you move through space, the slower you move through time. Not metaphorically, literally. This is not a psychological effect. It is not about perception. It is built into the geometry of space-time itself. Think of it like this. In space-time, you are always moving at the same total rate, but that motion is split between space and time. If you use more of your motion to move through space, you must use less to move through time. And if you don't move through space at all, like sitting still, then all of your motion goes into moving through time. This isn't poetic language. It's mathematical structure. Einstein discovered that space and time mix together when you change your motion. They are not rigid, independent dimensions. They blend. Let me show you why that has to be true. The speed of light is constant. No matter how fast you move, you measure light traveling at the same speed. If you chase a beam of light, you don't see it slow down. If you run away from a beam of light, you don't see it speed up. It remains constant. Now think about what that means. If two observers are moving relative to each other, and both measure the same speed of light, then something else must adjust. Distances must change. Time must change. Otherwise, the math doesn't work. And that's exactly what happens. Lengths contract. Time dilates. These are not illusions. They are measurable. Take atomic clocks, extremely precise clocks based on atomic vibrations. Put one on the ground, put another on a fast-moving airplane, fly it around the Earth, and bring it back. They will disagree. The clock on the airplane will have ticked slightly slower. That's not theory. That's experiment. It happens because moving through space changes how you move through time. Now let's make it even stranger. Gravity also affects time. If you place one atomic clock at sea level and another on a mountain, the one higher up ticks slightly faster. Why? Because gravity bends space-time. And where space-time bends, the rate of time changes. That means time is not a universal river flowing evenly across the cosmos. It's more like a landscape. It can stretch. It can compress. It can curve. And it does so depending on mass and motion. You may feel like you're living in a stable, ticking universe, but the structure underneath is flexible. When we say space and time are unified, we mean something precise. An event in the universe is not just described by where it happens. It's described by 4 coordinates, 3 for space, 1 for time. Change your motion, and those coordinates mix. What you call a distance in space, someone else partially calls a distance in time. The separation between events depends on your frame of reference. This is deeply counterintuitive because your everyday experience doesn't show it clearly. At normal speeds, walking, driving, flying, these effects are tiny. But increase the speed toward that of light, and space and time begin to warp dramatically. If you travel near the speed of light and return to Earth, you would age less than everyone who stayed behind. That's not speculation. That's a direct consequence of space-time geometry. And notice what that implies. If time can slow down relative to someone else, then time cannot be a universal background. It must be woven into space itself. You can't stretch one without affecting the other. Imagine drawing a grid on a rubber sheet. If you stretch the sheet in one direction, the grid distorts everywhere. Space-time behaves similarly. Mass stretches it. Motion tilts it. Energy curves it. And within that curved, stretched geometry, what you call time emerges as one dimension of the structure. This is why physicists stop thinking of space and time as separate arenas. They're not 2 stages glued together. They're one stage with 4 dimensions. You don't move through space and then through time. You move through space-time, always. Every moment of your existence is a path, what physicists call a world line, through this 4-dimensional structure. And depending on the shape of that path, the amount of time you experience changes. So when you ask, what time is it, you're really asking something local. Because somewhere else, moving differently, sitting deeper in a gravitational field, time is ticking at a different rate. There is no universal clock keeping everything synchronized. There is only space-time geometry determining how intervals unfold. This destroys the comfortable separation you were taught. Space is not the container. Time is not the ticking background. To invert to mutant teacher tornawaricals and welekroyen faisio. They are intertwined. And once you see that, the idea of a single flowing time shared by all observers becomes impossible. Time bends because space-time bends. Time slows because motion redistributes how you move through the fabric of reality. And the moment you accept that space and time are not separate, you realize something profound. The universe is not happening in time. Time is happening inside the universe's geometry. And that is far stranger than most people ever allow themselves to consider. 3. There is no master clock. Now let's remove the last piece of comfort you're holding on to. Even after accepting that simultaneity depends on motion and that space and time are fused together, you might still secretly imagine this. Fine, things are relative. But surely somewhere deep underneath it all, there's a real clock, a master clock, a cosmic reference that defines the true time. No, there is no master clock. There is no universal ticking mechanism behind reality. There is no central timeline that everything plugs into. And that is not philosophy. It is a direct consequence of relativity. Let's think clearly. If there were a master clock, then all observers, no matter how they moved, could compare their time to it and agree on what moment it is in the universe. But relativity forbids that, because time itself changes depending on motion and gravity. If you and I move differently, our clocks tick at different rates. Not because one of us made a mistake, not because one of us is measuring badly, but because space-time geometry demands it. If we start together, synchronize our clocks, and then I take off in a spaceship near the speed of light and come back, we will disagree about how much time passed. My clock will show less elapsed time. That's not theory. That's been tested. Particles moving near light speed decay slower than identical particles at rest. Their internal clocks literally slow down. So ask yourself, if there were a master clock, which one of us would be aligned with it? Mine? Yours? There is no privileged frame of reference in relativity. No observer gets special status. That means there is no universal timeline in the background. Every observer carries their own clock, and every one of those clocks is equally valid. Now here's where it becomes unsettling. Imagine two observers drifting past each other in deep space, far from gravity. They synchronize clocks as they pass. Then they continue in opposite directions. Each will later measure the other's clock as ticking slower. That sounds impossible, but it's true, because from each perspective, the other is moving. Time dilation is symmetric. You slow down relative to me. I slow down relative to you. That's not contradiction, it's geometry. Space-time doesn't assign one of us the role of correct. It only describes relationships between our world lines. There is no outside perspective, no cosmic referee, no ultimate clock in the sky declaring who is aging properly. And that destroys something deeply embedded in human intuition. We are used to thinking there must be a final reference point, a background stage, a hidden metronome, a universal pulse. But the universe doesn't work that way. Instead of a master clock, what we have is a network of relationships. Time is defined locally along each observer's path through space-time. Your clock measures your proper time, the time experienced along your world line. Mine measures mine. There is no third clock in the background to compare us against. Now take this idea and stretch it across the cosmos. When you imagine the current time of the universe, what are you imagining? A giant synchronized timestamp stretching across galaxies. That doesn't exist. Because observers in different galaxies moving differently relative to each other will slice space-time into past and future differently. There is no universal now. And without a universal now, there cannot be a universal clock. The idea of a master clock requires a single shared present moment. Relativity eliminates that. Instead, the universe is a four-dimensional structure of events. Each observer traces a path through it. Each observer experiences time according to the geometry of that path. And that experience is complete and self-contained. You don't experience time relative to a cosmic metronome. You experience time relative to your motion and gravitational environment. This has practical consequences. GPS satellites orbiting Earth experience weaker gravity than clocks on the surface. They also move at high speed. Both effects change how fast their clocks tick. If engineers ignored relativity and assumed a master clock for Earth, your GPS would drift by kilometers every day. But instead, we calculate time locally for each satellite, correcting for relativistic effects. The system works precisely because we do not assume a universal clock. We accept that time is frame-dependent. Now, step back. If there is no master clock, if there is no universal timeline, if each observer carries their own valid measure of time, then time is not an external thing flowing independently of observers. It is part of the structure that connects events. Time is not something the universe uses. It is something that emerges from how space-time is organized. This is why the search for a preferred frame, a special cosmic rest state, has failed. The laws of physics look the same in every inertial frame. Nature refuses to give us a privileged clock, and that is profoundly strange, because psychologically, we crave one. We want to believe that somewhere there is a true time, a final authority, a single ticking reality. But the universe does not provide that comfort. It provides symmetry. It provides consistency. It provides geometry. And within that geometry, time is local, personal in the physical sense, defined by motion and gravity, not dictated by a central command. So when you ask what time is it in the universe, the question has no absolute meaning. It only has meaning relative to a particular observer. There is no master clock. There is no global timestamp. There are only world lines weaving through space-time, and each of them carries its own time. That realization forces you to let go of the idea that reality unfolds on a single shared schedule. It doesn't. It unfolds differently along every path, and yet all of those paths coexist consistently within the same space-time structure. No master clock, no central timeline, just geometry. And that's far more radical than most people ever realize. 4. The block universe problem. Now we step into territory that makes people uncomfortable. If there is no universal now and no master clock ticking in the background, then you have to ask a dangerous question. What actually exists? You imagine reality as something unfolding. Newton, the past is gone. The future does not yet exist. The present is the only thing that is real. That's how it feels. But relativity quietly challenges that entire picture. Let's think carefully. In space-time, events are laid out in 4 dimensions, 3 of space, 1 of time. Every event that has ever happened, is happening, or will happen, has coordinates in this structure. Now here's the crucial point. Relativity does not privilege any single slice of space-time as the present. Different observers moving relative to each other slice space-time differently into past, present, and future. That means the idea of a universal present is not built into the structure of reality. If the present is not fundamental, then what is? One interpretation, and it's a serious one in physics, is that the entire space-time structure simply exists. All of it, not sequentially, not being generated moment by moment, but as a complete 4-dimensional object. This is often called the block universe. Imagine space-time as a massive, unchanging geometric block. Within that block are all events. Your birth, this sentence, tomorrow's sunrise, distant supernovas, civilizations that no longer exist. They are not being created as time moves forward. They are all embedded in the structure. Your experience of time flowing is like a spotlight moving along your world line through the block. But the block itself does not move. It just is. Now pause and let that sink in. If that picture is correct, then the future is not something that will be created. It is already part of space-time, just as fixed geometrically as the past. You do not experience it yet, but that does not mean it does not exist within the structure. This sounds fatalistic. It sounds like it kills free will, but physics is not in the business of protecting your philosophical comfort. It is in the business of describing consistent geometry, and relativity's mathematics does not require a flowing present. It describes a 4-dimensional manifold where all events coexist. The sense of becoming, of things coming into existence, does not appear in the fundamental equations. They describe relationships between events, not a universal ticking progression. Now you might object, but I feel time flowing. I experience the present moving. Of course you do. But that experience may be a feature of consciousness, not a feature of space-time. Think of a film reel. All frames of the movie exist at once on the reel. The story unfolds only because a projector moves light across the frames sequentially. The motion is in the projection process, not in the film itself. In the block universe picture, your consciousness is like that projector. Your awareness traces a path through space-time, experiencing events in sequence, but the events themselves are already embedded in the structure. This is deeply counterintuitive because your brain evolved to navigate survival, not 4-dimensional geometry. You experience change because your memory stores information about earlier states and not future ones. Entropy increases. Information about the past accumulates. Information about the future does not. That asymmetry gives you the sensation of forward flow, but that psychological arrow does not necessarily mean space-time itself is flowing. Now here's the unsettling consequence. If the block universe is correct, then the distinction between past and future is not absolute. It depends on your position and motion. Events that are in your future may already lie in someone else's past slice of space-time, depending on how they move. Relativity allows for different observers to disagree about the ordering of distant events. There is no global agreement on what is future and what is present. If you try to preserve the idea that only the present is real, you run into a problem. Which present? Yours? Mine? Someone moving at near light speed in another galaxy? All are equally valid. If you insist only one slice is real, you must choose a preferred frame of reference. But relativity gives you no such privilege. So the cleanest mathematical picture is that all events in space-time are equally part of the structure. The universe is not becoming. It is a four-dimensional entity, and your life is a world line within it, extended in time just as a line is extended in space. You are not a three-dimensional object moving through time. You are a four-dimensional object extended through space-time. You only experience one cross-section at a time. That idea is difficult because it challenges your sense of agency and immediacy. But remember, physics describes structure, not subjective meaning. The block universe does not say your decisions are illusions. It says your decisions are part of the structure. Your choice tomorrow is embedded in space-time just as much as your memory of yesterday. It is not waiting to be created. It is waiting to be experienced along your world line. Now, this interpretation is not forced upon us by experiment in an absolute sense. There are philosophical debates, but the mathematics of relativity is perfectly consistent with a block universe, and nothing in the equations demands a universal flowing present. That's the real shock. The universe, at its deepest level, does not seem to require time to pass. It only requires that events relate consistently within a four-dimensional geometry. The flow of time may not be fundamental. It may be emergent, a feature of thermodynamics, a feature of entropy, a feature of consciousness moving through memory, but not a built-in ticking of the cosmos. So the next time you think of the future as something that doesn't exist yet, remember, physics does not clearly support that view. The future may be as structurally real as the past. You simply haven't reached that region of space-time along your path. And if that's true, then reality is not a story being written moment by moment. It's a structure already there. You are not watching the universe unfold. You are traversing it. And that is a radically different way of thinking about existence. 5, the speed of light breaks common sense. Everything we've discussed, the loss of simultaneity, the absence of a master clock, the possibility of a block universe, traces back to one stubborn fact: the speed of light is constant. That sounds harmless at first. It sounds like just another number in physics, but it is not just a number. It is a structural rule of reality, and once you accept it fully, it forces space and time to reorganize themselves in ways that feel almost unreasonable. Let's begin with an assumption that feels natural. If you throw a ball forward at 20 kilometers per hour while standing still, and then you run forward at 10 kilometers per hour and throw the ball again at 20 kilometers per hour relative to yourself, someone watching from the sidewalk will measure the ball moving at 30 kilometers per hour. Velocities add. That is common sense. That is Newtonian thinking. It works beautifully for everyday life. Now replace the ball with a beam of light. If you shine a flashlight while standing still, someone measures light traveling at about 300,000 kilometers per second. That's the speed of light. Now imagine you run forward at a very high speed and shine the flashlight again. Common sense says the observer should measure light going faster than before. Your speed plus the light speed. That would match the ball example. But nature refuses to cooperate with that logic. The observer still measures light moving at the same speed, not faster, not slower, the same, always the same. That is the point where intuition collapses. If velocities do not add normally when light is involved, then something else must give way. You cannot keep all your assumptions and still preserve a constant light speed. So which assumptions must be sacrificed? Time, space, those are what break. In order for every observer, no matter how fast they are moving, to measure light traveling at the same speed, space must contract and time must dilate. There is no way around it. It is not a choice. It is a mathematical necessity. If you move faster through space, your time slows down relative to someone at rest. If you approach the speed of light, your time slows dramatically. From your perspective, everything feels normal. Your heart beats normally. Your thoughts feel continuous. But an outside observer sees your processes slowed down. Push this idea further. If you could travel at the speed of light, which you cannot if you have mass, time would stop entirely from your perspective. That is not metaphorical. Along a light beam's path, there is no passage of time. That is what the equations imply. The reason is geometric. In space-time, there is a fundamental limit that cannot be exceeded. The speed of light is not just about light. It is the maximum speed at which cause and effect can propagate. It is the conversion factor between space and time in the geometry of the universe. If that limit exists and remains the same for all observers, then observers must disagree about distances and durations in order to keep that limit intact. Imagine two observers passing each other at high speed. Each measures the other's clock ticking slower. Each measures the other's lengths contracted along the direction of motion. This sounds contradictory until you realize that there is no universal viewpoint from which to declare one observer correct. Nature does not preserve common sense. It preserves consistency of light speed. And once you accept that, everyday logic no longer applies at high velocities. The strangeness does not end with motion. Gravity also enters the story. Einstein later realized that gravity is not a force pulling objects in a traditional sense. It is curvature of space-time. Massive objects warp space-time around them, and that warping affects how time flows. A clock near a massive object ticks slower than a clock far away, not because of mechanical failure, not because of some hidden interference, because time itself runs at a different rate in curved space-time. Combine these two effects, velocity and gravity, and you realize there is no universal rhythm underlying the universe. There is no master pace. The speed of light enforces a structure in which time is elastic and space is flexible. Now think about what that means for the idea of now. If light speed is constant, then observers moving differently must disagree about the timing of distant events. This disagreement is not a glitch. It is a requirement. If you tried to enforce absolute simultaneity, a universal now, you would break the constancy of light speed. So nature chooses light speed over simultaneity. In other words, to protect the rule that light travels at the same speed for everyone, the universe sacrifices your intuition about time. That is why the speed of light breaks common sense. It forces you to abandon the idea that time flows uniformly everywhere. It forces you to accept that two observers can have equally valid but different descriptions of when events occur. This is not just philosophical abstraction. Particle accelerators confirm it. GPS satellites confirm it. Cosmic ray particles reaching Earth confirm it. When particles travel near light speed, they live longer than they should according to Newtonian expectations. Their internal clocks slow down relative to ours. Reality obeys light, not intuition. And here is the deeper insight. The speed of light is not merely about electromagnetic radiation. It is about causality. It is the speed at which information travels. It defines the structure of cause and effect in space-time. If you tried to exceed it, you would create paradoxes, effects preceding causes, contradictions in sequence. So the universe enforces this limit strictly. In order to maintain that consistency, it reshapes space and time. That is the trade-off. Common sense was built for slow speeds and weak gravity. It evolved in a narrow band of conditions where relativistic effects are tiny, But once you leave that comfortable band, common sense fails. The speed of light is the hinge on which the strange structure of reality turns. Because it is constant, space must contract. Because it is constant, time must dilate. Because it is constant, simultaneity must become relative. And because of that, there can be no universal now. Your intuition says time should be absolute and velocity should add. Physics says no. Light does not negotiate. And the entire architecture of space-time bends to accommodate that one unyielding fact. That is why the speed of light does not just illuminate objects. It illuminates the limits of your intuition. And once you see that, you understand why time cannot possibly be what you thought it was. 6. Your intuition is built for slow speeds. Now let's be honest about something. The reason all of this feels wrong is not because physics is unclear. It's because your brain was not designed to understand relativity. Your intuition was built for survival on the African savanna, not for navigating space-time geometry. For millions of years, your ancestors dealt with objects moving at walking speed, running speed, maybe the speed of a thrown spear. None of those speeds are remotely close to the speed of light, not even a fraction worth mentioning. At those speeds, Newton's physics works beautifully. Time appears universal. Clocks tick at the same rate. Simultaneity feels absolute. Velocities add in simple ways. Everything is predictable and consistent with common sense. So your brain internalized that model. It built shortcuts. It assumes time flows the same everywhere. Space is rigid. Events either happen at the same time or they don't. Motion is absolute in some intuitive way. Those assumptions are not stupid. They're efficient. They work extremely well in everyday life. But they are approximations, and approximations break when you push them outside their domain. Relativity does not contradict everyday experience. It refines it. It says at low speeds and weak gravity, your intuition is a good enough shortcut, but it is not the fundamental truth. Think about how shocking this really is. You feel time passing uniformly. 1 second feels like 1 second. You assume that same second is happening everywhere in the universe. But that feeling is not a measurement of cosmic truth. It is a local biological experience. Your brain tracks change. It records memory. It detects sequences. From that, it constructs a sense of flow. But nothing in your nervous system measures the structure of space-time directly. You experience time because your body processes information in a particular direction, from lower entropy to higher entropy. You remember the past because physical processes leave records. You do not remember the future because those records do not exist yet in your memory structure. That psychological arrow of time feels fundamental, but physics suggests it may not be. Now let's consider motion. You feel stationary, sitting in a chair, but you are rotating with Earth. You are orbiting the sun. You are moving through the galaxy. You are moving relative to the cosmic microwave background. There is no absolute rest frame. Yet your intuition insists there must be some meaningful sense of really at rest. Why? Because at low speeds, differences between frames are negligible. The relativistic distortions are tiny. You cannot perceive them directly, so your brain ignores them. It assumes a kind of universal rest. That assumption works at 10 meters per second. It fails at 200,000 kilometers per second. This is not unique to relativity. Quantum mechanics does the same thing to intuition. So does thermodynamics. Your intuition is not a truth detector. It is a pattern detector, tuned for survival at human scales. When physics moves outside that scale, intuition becomes unreliable. Now imagine a species that evolved near a neutron star, where gravity is extreme. For them, gravitational time dilation might be obvious in everyday life. Their intuition about time might be completely different. Our intuition is provincial. It reflects a narrow band of conditions. Relativity reveals that what feels universal is actually local. Time feels absolute because the relativistic differences around you are too small to notice. But precision experiments reveal those differences clearly. Put two atomic clocks at different altitudes, and they tick differently. Move one clock at high speed and it ticks differently. The effects are small in daily life, but they are real. Your brain simply lacks the resolution to detect them. And because it cannot detect them, it builds a simplified model of reality. That model is useful, but incomplete. Now here's the deeper lesson. When you resist the idea that simultaneity is relative, or that there is no universal now, what you are really defending is not physics, it's familiarity. You are defending the mental model that has worked for you since childhood. But nature does not owe you intuitive consistency. It owes you internal consistency. Relativity is internally consistent. It is experimentally verified. It predicts measurable effects. Your discomfort does not change that. So when you hear that two observers can disagree about what events are happening right now and both be correct, your intuition protests. But that protest is not evidence. It is inertia. It is the inertia of a brain adapted to slow speeds and weak gravity. Physics invites you to step outside that adaptation. It asks you to abandon the idea that your experience defines reality. Instead, it asks you to follow the equations, follow the experiments, follow the geometry. And when you do, you discover something humbling. Reality is not obligated to match human intuition. Your sense of time flowing is real as an experience, but it may not reflect a fundamental feature of the universe. Your sense of a shared present feels obvious, but it dissolves under relativistic analysis. Your sense that there must be a master clock feels comforting, but the structure of space-time does not include one. Once you accept that your intuition was built for a narrow slice of conditions, you stop expecting the universe to behave according to common sense. Common sense is local. Relativity is global. And when you zoom out far enough to high velocities, to massive gravitational fields, to cosmological distances, you see that the universe is not built around human-scale experience. It is built around geometric consistency. Your intuition was designed to keep you alive. It was not designed to understand space-time. And that is why time is not what you think it is. 7. The present is a perspective. Now we arrive at the point where everything you thought was solid starts to dissolve. You wake up in the morning and you feel it immediately. The present, it feels sharp, immediate, real. The past feels gone. The future feels open. The present feels like the edge of existence, like the front line where reality is actively being created. But physics does not find that edge anywhere. There is no glowing boundary in space-time labeled now. There is no universal razor slicing the universe into what exists and what does not. The present, according to relativity, is not a fundamental feature of the universe. It is a perspective. Let's unpack that slowly. In space-time, events are arranged in a four-dimensional structure. Every event, a star exploding, a child being born, you reading this sentence, occupies a specific location in that structure. Now, when you describe something as happening right now, what you are really doing is selecting a particular slice of space-time, a set of events you consider simultaneous with your current position. But, as we already established, simultaneity depends on motion. Change your velocity, and that slice tilts. That tilt changes which distant events are included in your present. For you sitting still on Earth, a certain event in another galaxy might be categorized as happening in the future. For someone moving rapidly relative to you, that same event might fall into their present or even their past. Both descriptions are consistent with the geometry of space-time. So which one is the real present? There is no privileged answer. Your now is defined by your state of motion. It is not written into the fabric of the cosmos as a universal boundary. It is constructed by how you move through space-time. This means the present is not an objective global feature. It is relational, local, perspective-dependent. Now let that sink in. Now let the thing you experience most vividly, the present moment, is not a universal property of reality. It is the way your world line intersects the structure of space-time. Your consciousness experiences events sequentially, because your brain processes information along a path. Memory accumulates behind you. Possibilities lie ahead of you. That gives you the sensation of a moving present. But that motion may not exist in space-time itself. It may exist only in your experience. Consider again the block universe picture. In that view, all events coexist in the four-dimensional structure. Your awareness does not cause the universe to unfold. It simply traces a path through what already exists geometrically. You feel the present moving because you cannot access the entire structure at once. You are embedded in it. A two-dimensional being living on a sheet of paper might experience a line sweeping across their world as the present, but from a three-dimensional perspective, the entire sheet exists at once. Similarly, from outside the space-time structure, if such a perspective were meaningful, the distinction between past, present, and future might not be fundamental. Now here's the psychological shock. Newton, if the present is a perspective, then the specialness you assign to this moment is not written into the universe. It is written into you. The universe does not glow at the edge of time. It does not pulse with a synchronized beat across galaxies. It simply contains events. The separation into past, present, and future depends on how observers move and how entropy structures information. Entropy plays a role here. The reason you remember the past and not the future is that entropy increases. Physical processes leave records in one direction. That direction gives you the arrow of time. But the arrow of time is not the same thing as a universal present. It is a thermodynamic asymmetry. Your experience of now arises from that asymmetry and from the limitations of your perspective. Now think about what this does to your everyday language. When you say the universe is happening right now, you are projecting your local experience outward. But physics says there is no single right now spanning the cosmos. There are countless overlapping slices, each defined by different observers. Each slice is valid within its frame. None is privileged. This is deeply unsettling because it removes the idea that reality is unfolding in a synchronized global moment. Instead, reality is a structure. Your present is a viewpoint within that structure. Change the viewpoint, and the present changes. That does not mean everything is subjective in a chaotic sense. The structure of space-time is objective. The relationships between events are objective. The geometry is objective. But the labeling of events as past, present, or future depends on the observer's motion. And once you accept that, the present loses its absolute status. It becomes a coordinate choice, a slice, a perspective. Now that does not make your experience meaningless. It makes it local. You are not witnessing the universe being created moment by moment. You are traveling along a world line through a four-dimensional landscape. You experience the present because you cannot step outside your path. You experience flow because memory accumulates in one direction. But the universe itself may not flow. It may simply be, and your now is just the point where your awareness intersects that being. That is the final break with intuition. The present feels fundamental, but physics suggests it is emergent. And once you understand that, you realize something profound. Time is not a river carrying you forward. You are a trajectory embedded in a structure. The present is not a universal event. It is your perspective on the geometry of space-time. And that is far stranger than the simple idea that time just ticks forward. So let's step back and look at what just happened. You began with a simple assumption that time flows, that there is a universal now, that the present moment is shared across the cosmos like a synchronized heartbeat. Physics quietly dismantled that. Simultaneity is not absolute. Space and time are fused together. There is no master clock. The universe may not be unfolding. It may simply exist as a four-dimensional structure. The speed of light forces reality to abandon common sense. Your intuition was built for slow speeds and weak gravity, and the present itself turns out to be a perspective, not a cosmic fact. None of this is mystical. None of it is poetic exaggeration. It comes directly from consistent mathematics and experiments that have been repeated and verified. Time slows down when you move faster. Time bends in gravity. Observers disagree about what is happening right now, and both can be correct. That means the universe does not contain a single shared present moment. Your now is local. Your experience of time flowing is real, but it may not be fundamental. And here's the most important realization. When physics removes the universal present, it doesn't make reality meaningless. It makes it deeper. It tells you that what feels obvious is not always what is fundamental. It tells you that intuition is not the final authority. It tells you that the universe is structured in ways that human scale experience only approximates. Time is not a universal river sweeping everything forward. It is part of the geometry of existence. You are not standing on the edge of creation as it unfolds. You are tracing a path through space-time. And the moment you accept that there is no universal now, you stop thinking of time as something external carrying you along. Instead, you begin to see that time, as strange as it sounds, is woven into the very structure of reality itself. And once you see that, you can never quite look at the ticking of a clock the same way again.